it immediately went live. That's odd. Okay. That's new. Anyways, hi everyone. My name is Ian McLaughlin, and I'm a PhD in neuroscience. I study the neurobiology of addiction and anxiety here in Philadelphia at the University of Pennsylvania. And there was a hell of a study that came out of MIT that focuses on how humans develop the ability to read and write. So, pretty important part of human evolution, right? And sort of central to basically everything we do. Like how much of your day is spent, just talking to other people, talking to yourself, or, texting or DMing people, or, thinking about things but using specific words to define those thoughts. Well, there's a word that scientists use to describe this specific capability. The ability to use your visual system to interpret letters, even letters written in different handwriting, fonts and sizes and colors and so on, orthographic processing. So I'm particularly grateful for orthographic processing because I have notoriously terrible handwriting. And by the way, just as a side note, the entire reason that I have such terrible handwriting arose from a very specific evening I spent with a friend of mine in high school who ended up becoming an architect, who said that they thought writing should be visually beautiful. So, of course, they had the artistic talent to make their handwriting visually beautiful. I have no such talent, and so my handwriting is just torturous to endure. However, despite all the chaos, people can still, if they try hard enough, understand what I'm trying to write. But even if you hadn't had to endure handwriting as bad as mine, you might have experienced similar expressions of this thoroughly human capability. So maybe like the most overt example is graffiti. So, where people are producing an artistic representation of words or names. Even more commonly, though, signatures can tend to be a bit interpretive. And I'll admit that my signature is thoroughly undecipherable because at a very young age I decided that the idea of having to write my full last clunky name in cursive was just intolerable. My normal script was indecipherable, and why even try and venture into cursive? So, this capability doesn't apply to signatures like mine, right, where it's just a kind of a shape. But I think you get the idea, right? It's this generalizable capability that we have, after learning to read, to interpret a wide range of variations on the shapes of letters and not only understand the words that are being written, but the concepts that are being conveyed with them. And so that's what we're talking about here when it comes to orthographic processing, the ability to decipher a diversity of penmanship, artistic expressions, and so on. And so we don't really know how this capability arose in humans or why it didn't arise in other primates, or at least to the same extent. After all, it's kind of wild to think about this, put it in evolutionary terms, but this capability hasn't existed for all that long, like evolutionarily speaking. It's not like Homo sapiens were writing things down 100,000 years ago, at least to the best of our knowledge. At least if they were, we don't have records of them doing that. And as far as I'm aware, evidence of writing has been found in a few different parts of the world around the same time, several thousand years ago. So, quite a while ago, of course, relative to how long humans live, but not that long ago. So the question that emerges in the brains of neuroscientists is, it's not like, these Homo sapiens in totally disparate parts of the world, like in the general areas of Egypt and in Mesopotamia and in China, would have just spontaneously and independently created new parts of the Homo sapien brain that could produce this capability. So, how do we explain the emergence of this absolutely critical capability? Well, the most reasonable hypothesis would be that brain regions that had been applied to other tasks, subject, to other kinds of evolutionary selective pressures, were capable of being co-opted for this totally novel task. So, there are a bunch of interesting examples of this arising, but this group at MIT hones in on the inferior temporal cortex, which is if you were to imagine the brain looking like a fist, it's kind of hard for me to, because you have to see the fist. Then it would be sort of like a strip of the brain that goes from the bottom of your first thumb knuckle, to your second thumb knuckle. So anyways, a theory to explain the emergence of this capability is that a neuronal pathway that includes this anatomical region, this ventral visual processing stream, ended up being co-opted during the evolution of Homo sapiens. And ventral processing, this ventral visual processing stream, just means like a set of connections between various brain cells that tend to be towards the bottom of the brain. And so the authors of this study note that this whole network is pretty well conserved among other primates, meaning like we're not the only primates that have something that looks a lot like this circuit in our brains. They note that, for example, old world monkeys, things like baboons, and my favorite, the proboscis monkey, have similar anatomical structures in their brain. And that a lot of research has demonstrated a lot of similarities between the visual systems of Homo sapiens and other primates. And there's sort of a funny, and I'm not sure totally intentional, but still kind of funny part of the intro to this paper. But in all fairness, that they're citing another paper, but still, here's what they note: baboons can learn to visually discriminate 4-letter words. I'm probably the only person who honed in on that sentence in this study. Of all the people that have read it, and it's going to be a lot because it's in a prestigious journal. What can I say? I have a 1.5-year-old. I have a connection with the child in my brain. I'm seeing the world through a baby's eyes. But the point that they're making is that baboons can derive meaning from simple written words. And there's a pretty meaningful similarity in the neuroanatomy of other primates and humans. So given this similarity, the group worked with rhesus macaques with the hypothesis that there'd be something like a precursor to this response to written letters and words. And that's what they found. So by measuring the activities of neurons in this particular strip of the brain in macaques, they came to the argument that there's a population of neurons in the inferior temporal cortex that's likely able to be versatile enough to be a substrate for this capability. And for the capability to understand, a variety of visual stimuli, including written language. So in other words, there seem to be some neurons in this part of the brain that can be applied to a bunch of different forms of visual information. We just happen to be the recipients of primates that, evolved such that this capability was favored. And so the group used a bunch of other techniques to evaluate whether a macaque could truly identify a word. But the point is that they're adding evidence to the theory that parts of our ancestors' brains that were devoted to object recognition, meaning if you're looking at a blade of grass, that it's going to be sort of flimsy, that it's not particularly rigid, and then you can't use a blade of grass to defend nor feed your family, right? They're adding evidence to the theory that the same brain regions that of our ancestors that generated that capability ended up being co-opted for the development of language or orthographic capabilities. And so we inherited this brain region that was devoted to recognizing blades of grass, and chance and circumstance resulted in the production of language. And it's worth noting that it's not like these brain regions were just sitting there doing nothing, right? The authors of the study used the term recycling, not a term that they invented, that this is a term that's used in neuroscience, but a term that they're intentionally using to mean that there were neurobiological systems that were useful or even critical to some necessary function that one of our distant ancestors had to execute. And so, in other words, it's not like there was this empty, abandoned space in the brains of our evolutionary ancestors that was just ripe to evolve into the language processing circuit, right? Rather, a part of the system that was involved in recognizing, understanding, and discriminating visual information ended up also being able to receive and project deeper meaning underlying, simple shapes in succession, meaning letters and words. I'm always kind of a sucker for studies like this one, studies that explore the evolutionary history of human consciousness. It's a super interesting thing to observe how incredibly intelligent other primates are, like macaques or chimps or bonobos, or honestly other animals in general. But it's also fairly mind-blowing that such subtle genetic differences and neuroanatomical differences produce such radically different capabilities between humans and other primates. And that said, I'll be honest that part of the reason that this study stood out to me is because there's a debate, a good faith debate, regarding how to navigate the education of children in the era of COVID-19. It's a super complicated debate for a variety of reasons, some of which are due to just the lack of a basic understanding of the virus, and an accurate calibration of who's really the most at risk, and cost-benefit analysis regarding yes, there's a risk, but then there's a known risk that if kids around the age of 3 to 5 aren't learning how to read, you're losing you're losing out there, and that's a significant cost. And so, I purposefully haven't gone into that topic despite having very strong opinions, because I don't have anything beyond questions and concerns really to competently offer. However, I am concerned that there are kids who really do need to learn things as simple as how to read, and it's optimal that they do so in a certain window of development. If we don't come up with a safe and effective way to do that, there will absolutely inevitably be severe consequences that reverberate for a very painfully long time. Another study that explores the evolutionary history of the human brain. I hope you thought it was as interesting as I did. Let's go ahead and start the live half. Hello, everyone. My name is Ian McLaughlin, and I have a PhD in neuroscience. And on YouTube, YouTube channel, youtube.com/anthropoid, I just talked about a study that basically explored how it is that humans develop the ability to read and write. The evolutionary sort of trajectory that explains why, and fairly recently, we developed the ability to read and write. Just a couple thousand years ago. As far as we're aware, humans weren't writing things, 100,000 years ago. And interestingly, that it arose spontaneously in totally disparate parts of the world, like China and Egypt and Mesopotamia, in different ways, of course, but the same underlying neurobiological substrate is shared and also used for the same reasons in the same ways, despite language being pretty radically different in some cases. Hey, hello, Nora, good to see you. I also just sort of. Let's just get into it. So, why do we walk in a room and forget why we're there so much? Yeah, that is super frustrating, right? So that shouldn't happen super recurrently. Like if that's happening regularly, that could be a sign that there's something worth evaluating, whether there's some kind of neurobiological deterioration, neurodegenerative condition. But part of the reason is that human memory is not perfect. I mean, it feels so effective, right? And it is this magnificent capability that we can essentially go back in time cognitively, and not physically, but cognitively. But despite the fact that it is so wonderful and we're so lucky to have it, it is fallible, very fallible, notoriously fallible, which is part of the reason for why our over-reliance on eyewitness reports in criminal law is problematic, because people misremember things. And by the way, whenever the event of remembering something is obviously a neurobiological event, but what happens to a memory, let's say next week you're going to be you're just like, oh, I was having this weird conversation with this neuroscience guy, and he talked about why we forget things, and I'm pretty sure he was wearing a red shirt, or probably not red, but a blue shirt. Or you could remember, like, oh, he was wearing this weird funky sort of blue shirt with like spots on it, but as you're remembering this conversation, the memory becomes malleable, more malleable than it would be had you not remembered it, meaning sort of specific qualities of the memory, specific features of the memory can change. And the reason for that is every time you're remembering something, proteins are being synthesized, neurotransmitters are being released, synaptogenesis, long-term depression, or the synaptic pruning, I guess. It's not really synaptic pruning, but the loss of synapses is occurring. And so as a result, memories become malleable and they can change because the very neurobiology that underlies your ability to remember things is changing. But anyway, so human memory isn't perfect. That's part of the reason. Another reason could be if you're going into the kitchen to whatever, wipe a counter or something that's sort of not particularly critical. Then the emphasis, the importance, the salience of a given intention just isn't as strong, and so other things come into your mind and they become dominated. So that's sort of a general explanation, but if it is happening to you regularly, it is something that's worth checking out. All right, so looks like we're getting a caller. Grow our own food. Hey, I love it. I'm growing my own food. Some 2 different kinds of basil. Oh, and culantro. If you don't know what culantro is, you're missing out. If you like cilantro, culantro is like the cooler cilantro. It's a stronger tasting cilantro. It's really common in the Caribbean, and I think in parts of Asia as well. It looks like we're having some difficulty connecting with Grow Your Own Food. Sorry, man. But it looks like we're getting another caller. Let's see. Hopefully there's not just like a problem with connection. Let's see. Glad to see you, Pasha. Thanks for coming by on the YouTube. So how do you call? So you hit that little... Actually, I don't know what it looks like for you, but there's like two little faces, one face behind the other face, and that should let you call in. But it looks like we're having trouble connecting, so hopefully that isn't permanent. Oh, of course I forgot. Every single time. Talking about or speak of, the fallibility of our memory, right? This just makes it easier for me to see comments. Okay. And where is the... There we go. Culantro is old and busted. New hotness is Cooliander. Yeah, right. Good to see you, Scott, by the way. How do I strengthen my memory? Well, so memory is it's so complicated. Like, it's kind of unfortunate that we use like one word to describe the complexity of memory, because there's different kinds of memory. That's the most sort of central reason that it's a little bit troubling or a little bit difficult to talk about memory in a comprehensive way. So, for example, you have declarative memory or episodic memory, remembering what you had for breakfast or dinner last night, or remembering where you were when you had your first kiss. But then there's declarative memory, like remembering that 1776, the birth of the United States or whatever. By the way, did you know the New Jersey state constitution was signed 2 days before the United States Constitution was signed? Kind of cool. It was a crappy state constitution at the time, and only a couple decades ago it became one of the best state constitutions in the country. It's become a model of what state constitutions should look like. Weird factoid, right? But remembering that is declarative memory, and these are... Oh, and then you have procedural memory, like your ability to remember how to ride a bike even if you haven't ridden one in like 20 years. So these are all different kinds of memory, and they will respond to different kinds of activity. And so, like, fundamentally, any like answer about how to improve memory is essentially going to boil down to use it, like rely on it more than you are. We have a lot of opportunities to sort of offload the sort of cognitive burden of remembering things like phone numbers and that kind of stuff. And so as a result, your capabilities, the capabilities that underlie that ability, will deteriorate. Atrophy isn't really the right word, because it's not like they're being damaged from misuse, but they're just not being emphasized. They're not being sort of, that machine isn't being run, and so as a result, your capabilities will decline. So, I mean, there is no one-size-fits-all answer for how to improve memory, but fundamentally, if there were to be one, it would be rely on it more. Okay, you live in New Jersey now. No, I'm working in New Jersey. I have a new job. And somebody wanted to talk about the mic. I forgot what it's called, but yeah, here, it's the MXL 990. I got it on eBay for like a steal. But yeah, it's a pretty good mic. I like it. Unfortunately, the mic stand is broken. So I'm sort of like propping it up so it's not just like dangling. But anyways, I read that there has been evidence of consciousness continuing several minutes after death. So that almost certainly is going to depend on what that person, what that scientist or whatever, is considering to be technically death, right? I mean, if for example, if you're a physician, you might consider the moment that heartbeat, cardiovascular rate declines to zero, and there's no outward manifestation of consciousness, maybe that's death. Or respiration has ceased to occur, and that's a fine definition of death. A neuroscientist would almost certainly prioritize when there's zero higher order, electrophysiological, electrochemical activity in the brain. But that, for all intents and purposes, you are not experiencing the world. Your body can be sustained, however, you can be kept alive, despite the fact that the brain isn't participating. And so, the point being, like, there are different sort of like definitions of what technically qualifies as death. Oh, here we go. So, if there is no electrochemical activity in the brain, meaning neurons are just not doing anything, none of the neurons are doing anything, I think any scientist would be very hard pressed to demonstrate that that consciousness remains. They are sort of one and the same. Consciousness emerges from that activity between neurons. And so, so I would like to see the argument that somebody might be making. I would be shocked if that person who's making that argument is a neuroscientist. Okay, what are your thoughts in dreams and in sleeping? Sure, that's a great topic. In fact, it's a far more interesting topic than I thought. So I have a podcast called Wired to be Weird, and we did a couple episodes on dreaming. I anticipated that it would be like a 15-minute, podcast episode, just like, explaining like when they happen, why they happen, and then boom, done. But no, there's a lot that we can learn about human biology and human consciousness by understanding dreams. But I imagine usually when people bring up dreams, what they're really asking is like, why do we have them, and are they important? Do they do something for us? So first of all, why do they happen? We don't know precisely why, but a really good explanation could be that while our brain is developing, while we're still a fetus, and neurons are being created and they're forming the connections that need to be made for you to have a functional brain, there needs to be activity. Those neurons need to speak to one another for them to be able to connect, at least in many cases. And so there's just spontaneous activity in the brain of a developing fetus. And that continues right up until the day that you're born. And in fact, there is what we consider to be what looked a lot like REM sleep, and REM is a phase of sleep during which we think most dreams occur. It's a period while you're asleep that the brain looks almost like it's awake, with a few important distinctions, some of which are what enables some people to have lucid dreams, and very rarely, but in some cases, right? So there's this spontaneous activity that needs to occur while our brain is developing, and then you're born, and your brain is still developing, right? Like my daughter, a bit over a year and a half old now, her brain is still very much so growing, it's just remarkable to see how quickly she learns things. It's like a superpower. It's also like you have to be careful, like, because I don't curse all that much, but sometimes I do, right? I kick a box or something, and I swear, right? And she sees me doing that, and so I don't want to no, don't do that. Do as I say, not as I do, right? As all parents basically at one point or another feel. But anyway, so there's a spontaneous activity that's happening in the brain, and it's continuing after you're born. And so when you're asleep, it's not like that activity stops. Right, so that pattern of spontaneous activity that enables neurons to connect to other neurons that they need to connect to just continues well on into adulthood. Probably because there's no selective pressure. There's no reason that the brain doing that would make it less likely that somebody would reproduce. Right, so it's just continuing to happen. And the brain's consciousness is going to be conscious, right? And so if there's spontaneous activity in the brain, whether it's derived from external stimuli or memories, or it's just generating activity on its own, consciousness is going to be conscious. Those brain regions are going to interpret that activity just as they would if you were awake. And so thus dreams are born, right? That's what dreams almost certainly come from. Now, there's also very likely an important or a useful component of not the dreams themselves, but that the things that cause us to have dreams, and that is almost certainly associated with learning and memory. Like when you learn, a new skill, a new language, a new way to dance or whatever, that process takes time. Obviously, a new musical instrument, right? You're not like perfect. It's not like you could read a book about how to play, guitar like Polyphia, which if you've not heard this band Polyphia, mind blowing. They're so talented, these kids. Anyways, and so that takes time, and we know that if you prevent an organism, even a human, from having that REM phase where there's that spontaneous brain activity, their ability to learn new skills is going to be severely disrupted. They're not going to, let's say you have two humans and you want to test out, does dreaming or does REM sleep, is it important to learning a new skill? So you have two humans that don't know how to play the guitar. You have them go through lessons, right, at the same rate, the same exact lessons even, in the same room, right, and same time of day, everything is the same, except one of the humans you prevent from ever having REM sleep, or you reduce their ability to have REM sleep. That person is going to be able to learn the guitar, but far more slowly than the human with intact REM. So the final thing is, there's this it's appealing to think that the experiences you're having when you're dreaming is sort of like your subconscious trying to teach you something, or trying to communicate something to the conscious part of you. And there's really no evidence to suggest there's no reason to believe that's the case. Part of the reason being that, crafting meaning, crafting some kind of, communicated thought, require certain parts of the brain that aren't as active when you're sleeping. But in terms of meaning, another theory of dreams is that they are amplified when you've had a novel experience, right? When there was something that happened that was surprising the day before you went to sleep. Certain patterns that emerge during dreams tend to be amplified or increased. And so it's sort of like, one of the old theories of dreams is that it's like a rehearsal, right? So your brain is just automatically sort of preparing itself to account for the, contingency that you encounter that surprising event again. So it becomes less surprising. You're sort of practicing. I think that's a kind of a problematic way to frame it, but, it does make sense that, just sort of replaying patterns of brain activity that occurred during the previous day would enable one to learn those things, to learn those skills or whatever more effectively. But it's an important distinction. It's not the dreams themselves that is what accomplishes this. It's not the fact that you're having a certain dream. It's really the patterns of brain activity that are occurring. And the dreams are just a byproduct of that happening. So that was a long spiel, huh? Gosh, thanks for sticking with me through that. But check out the podcast episodes. I think they're really cool. I think they're one of the coolest ones we did. Wired to be Weird is a podcast. Do you think it'd be possible to ever go into other people's dreams a la Inception? So, sort of. I mean, so yes. I mean, if you accept, as I do, that at some point in the future, if we continue learning more and more about the brain and consciousness, and if we continue developing and refining technologies that enable computers to interface with the human brain, and if you accept that that's going to happen, and you accept all the capabilities that would afford us, new capabilities that are, the wet work of our primate brain could never accomplish, but adding this technology into the brain allows us to more directly interface with other people's brains, then, one ramification of this, or one manifestation of this, would be the ability to experience the conscious experiences of somebody else, right? So, I did a podcast episode, podcast called Wired to be Weird, and on whole brain computer interfaces, and we sort of used Elon Musk's company Neuralink as the kind of framework for the debate, or not the debate, the discussion. But it's not just Neuralink, and that's not the only company that's trying to develop these whole brain computer interfaces. I extrapolated and I speculated about what it would be like if we had a whole brain computer interface, what we could do. And so, for example, let's say you're sitting at your desk, probably at home these days, doing some work, and your wife is across the country, maybe she's at Lake Tahoe or some beautiful, she's in front of the redwoods, and she wants you to experience that. She wants to convey that the majesty of this wonderful, transformative, transcendent experience. She could, today she could, FaceTime you or video chat with you. She could just text message you and just be like, wow, this is so cool. But if we had whole brain computer interfaces, she could just ping your whole brain computer interface, and suddenly you just experience that there is somebody else, or somebody that you know, that you love, theoretically, needs you, or is interested in communing with you, right? Communicating with you, and you're just sitting at your desk, and then that awareness pops in, and she doesn't have to send any words. She just sends the intention to share this experience she's having, and so you just know that she wants to do that. And this would occur in many different ways, but like she could give you a sort of a picture-in-picture kind of experience of what she's seeing, right? Where you're just looking at your computer screen, and like down here you're seeing, or in the middle or whatever, you're seeing what she's seeing, literally what she's seeing. And then you're like, whoa, this is so beautiful. Can I experience that right now, like through you? And then you give her access to the entirety of your sensory systems. And so now not only are you seeing the redwoods, you are smelling the forest, you are feeling the cool air around you, you're hearing the sounds of forest creatures. And you are no longer sitting at your desk, right? You are now, for all intents and purposes, you are there. And then you're like, okay, thanks for doing that, but I have to finish this report, blah, blah, blah. And then you disconnect. So if you accept that someday that technology could exist, as I do, as many neuroscientists do, then absolutely there'd be no reason that you couldn't experience another person's dream in real time. So, yeah. It's an interesting topic. Okay, how does the brain... what? Okay, interesting. We don't seem to have a full grasp on consciousness. What are your thoughts on that, Doc? Don Dada. We have a pretty good grasp of consciousness. Like, there is this tendency among some neuroscientists, and oftentimes they're either cognitive neuroscientists or they're philosophers. They're neurophilosophers who never really did any neuroscience research. Nothing wrong with that. I mean, neurophilosophers are critical to articulating the discoveries that we're making and sort of knitting them together into a coherent tapestry, right? As opposed to just a bunch of disparate studies like, oh, this person, found out that the nucleus accumbens receives a ton of dopamine when, when you smoke a cigarette, or when you drink alcohol, or essentially any drug that you do for fun, right? Oh, okay, there's that, right? And now we know that. But then this other group found out that it turns out that when, when you think of somebody whom you love deeply, there is this increase in activity in the very parts of the brain that actually send dopamine to the nucleus accumbens when you smoke alcohol, when you smoke cigarettes or drink alcohol. And you get, it's a similar elevation of dopamine. And it's a totally different thing. Okay, well, now we know that, right? Now we know that ventral tegmental dopaminergic neurons are, elevate in activity when you think of somebody you love, and they also happen to underlie the fact that alcohol feels good. Okay, so now a neurophilosopher can knit those together and have them make sense, and are typically better writers than scientists. But there is this tendency, and sort of David Chalmers is a very famous neuroscientist, who basically made his career on making the argument that there are certain questions we'll never be able to answer about consciousness, and so therefore there is no amount of understanding that would qualify as understanding consciousness, because what he's saying is that none of these discoveries are actually answering the hard problem, the hard questions. And, he's sort of been left in the dust, frankly. Not by people like me, lowly PhDs, but, other highly accomplished neurophilosophers like Thomas Metzinger, and it's just like, that's just not true. People have made that argument for decades, for centuries about science, in science. Like, oh, yeah, it's fabulous that you've, discovered that, the sun doesn't revolve around the earth, rather the earth revolves around the sun. That's great. But we'll never be able to understand, how the earth formed. I mean, that's impossible, right? Well, no, actually we know that now, right? And so the same, I think, applies to neuroscience and consciousness. That is not to say we totally understand consciousness. Of course not. There are many questions that remain to be answered, but there's no law of physics that prevents us from answering those questions, right? It's just a deficit of understanding, a deficit of knowledge. And humans are very good at creating knowledge, given enough time, given enough investment and energy, and consciousness. So I think we do understand quite a bit about consciousness and how it functions and the neurobiology underlying it. And, that's just not true. Like, just because there's more to understand doesn't mean that we don't understand it at all, right? Okay. Sorry, I'm way behind. Okay, well, magic mushrooms help my PTSD. Detroit's Grifter. Very interesting topic. There is some evidence to suggest that they might. Some strong evidence, I should acknowledge. However, the evidence is derived from essentially clinical trials. I mean, they're not like formal clinical trials, but they're, psilocybin, either pure psilocybin, which is the active ingredient of magic mushrooms, or magic mushrooms themselves, right? Psilocybin containing fungi. And they're administered by a clinician of some sort, a psychiatrist, and there's a psychological counselor present, and so you're not just like, it's not the pharmacology of psilocybin that is the therapeutic agent. It is a combination of that altered state of consciousness and some kind of psychotherapeutic treatment. But there is some evidence to suggest that yes, it may help. Another drug that's sort of bucketed in the same category of illicit substances, MDMA or Molly or ecstasy, or there's a bunch of different words for it. There are, I think, arguably more robust evidence that MDMA may be quite helpful for the treatment of PTSD. Specifically, these are studies that are conducted by an organization called MAPS, and they are basically, I think they might have actually started their phase 3 clinical trial, which, to give you a sense, that is, depending on how you're structuring FDA approval, that could be the last thing that they need to do before it's in your physician's office, right, ready to be used, to be deployed whenever somebody has PTSD. And there's been enough good, compelling evidence in the face of tremendous opposition, like prohibitionist opposition, suggesting that MDMA is pointless and dangerous, and it's just a drug that people do for fun and it's frivolous. But no, I mean, they're demonstrating that actually it does have some potential clinical utility. And these are studies, I should note, specifically evaluating its utility in treating people with PTSD that was induced by sexual trauma. So it's just worth acknowledging that it could be the case that different forms of PTSD may respond more or less, with a higher or lower magnitude or whatever than that kind of PTSD. All right, let's talk about the Nick. Go. The Nick is Joy, of course, brings it up. Thank you for bringing it up. She knows that's like my favorite TV show of all time. You should all watch the Nick. It's awesome, particularly now when we have, if you're being a good citizen, a good member of the human species, at least in the United States, if you're staying home most of the time, I recommend it. It's awesome. It's basically a story of like the kind of early phase of the development of medicine in the United States, but really in the world. The United States was sort of medicine wasn't standardized in the United States until after it was in, I think, Germany. It was really like the first country that was it Germany or was it France? It was Europe. And medicine in the United States was just this kind of patchwork of wasn't really evidence-based, and basically Johns Hopkins University is like where medicine became a respectable discipline in the United States. It was standardized there, and Johns Hopkins was founded by essentially 4 dudes, because of course back then it was going to be dudes, and one of them, and so the show The Nick is based off of one of them. I always forget his name. It's like William something, and he was a notorious cocaine addict, severe cocaine addict, but also extraordinarily brilliant and completely transformed medicine in the world, but severe cocaine addict, and fortunately for him, there was a cure for cocaine addiction at the time, heroin, and so he then became a heroin addict. Anyways, so the show goes into that kind of stuff, and it's very, very cool, and it's sort of it is it makes an attempt to be based on sort of true events. And the show, it makes you wonder about how all these techniques were developed. Like, when did people begin wearing gloves when they conducted surgery? And surgery was even worse than medicine at the time. I mean, it was just like a mixture of carpentry and like being a barber. And so surgery was being refined and made more sophisticated at the time. Anyways, the implicit kind of argument that the show is making is like, what are we going to look back on today about medicine today and think, oh my God, how barbaric we were, frontal lobe lobotomies, like, oh my God, and things like that. Then that was very recently being deployed. So, anyways, check it out. Okay. Wrong. I've been a doctor for 27 years and read all medical research on this, and you are wrong. All medical literature, I'm sure. What are your thoughts? What are your thoughts on the word genius, and what does studies say about them? Yeah, I don't have really deep knowledge of the neurobiology of underlying genius. I think it's kind of a tortured word. And I think people mean different things when they say the word genius. So yeah, I mean, I guess maybe we can have a productive conversation where about like Albert Einstein, right? I think everybody would agree, regardless of what you think qualifies as a genius, you would agree that Albert Einstein was a genius. And if you wouldn't, then you have a very high bar for what you consider to be genius. And in fact, actually, you can see parts of Albert Einstein's brain in Philadelphia at the Mutter Museum. If you ever come to Philadelphia, go to the Mutter Museum. You're making a huge, critical mistake if you don't go to the Mutter Museum. If you have any interest in science, I should say. Anyways, so Albert Einstein was a genius. He fundamentally transformed the way we understand our physical world. And so there has been, for a long time, and this is so unfortunate, if you were to see Albert Einstein's brain, you'd be like, why is it preserved this way? This is like so rudimentary. Like the way I preserved my brain samples, it's not like I was, going to using the most sophisticated, preservation methods or histological methods, but like my brain specimens will be much better for much longer than Albert Einstein's brain, which is just tragic because and the story of Albert Einstein's brain is wild. His brain just went missing for years, and it was eventually discovered, like sitting on a shelf in some office somewhere. Wild. So like somebody literally stole his brain. Anyways, one scientist could scrutinize his brain. There was an argument that he had a very specific distinction in a certain part of the brain called the Sylvian fissure. Essentially, it's if you look at the brain like a fist, it's essentially like this little line right here. Or actually, it might be whatever. It's one of the inward wrinkles or the sulci. It seems truncated. Seems like it's not there. And there's some dispute as to whether or not that's true. There are some neuroanatomists that argue like, no, that's probably a misunderstanding of partly due to how badly his brain was preserved, but also, his brain was sectioned in ways that, you can't really be sure that that's true. But there are definitely neuroscientists who argue that, yes, it was true. And so he had a very, very unique neuroanatomy. There was also, I believe it was shown that he had rather low incidences of aggregates throughout his brain. I don't know if that's been demonstrated really conclusively, but regardless, yeah, there's something different about his brain. And and given anatomically, where these unique components of his brain were, it could be the case that, parts of his brain that were devoted to object recognition, spatial awareness, these types of things were more directly associated with parts of the brain that, I should say spatial awareness were more directly associated with parts of the brain that were associated with like computation, symbolic representation, the use of like, even like, the use of symbols to represent concepts and things like that. So it could be the case that like, yeah, he was a genius, and he was a genius because his brain was so unique relative to other humans. I think that that's as good a definition of genius as any, where somebody has such a unique brain that they're able to interact with the world in a way that's just inaccessible to humans who don't have those unique facets. And by the way, like, that is something that, like, that's true about a lot of psychiatric conditions where, you know, John Nash, right, a very famous, I guess, game theorist, mathematician, came up with game theory, a bunch of other interesting things too, about which I'm no expert, but he had schizophrenia, severe schizophrenia, and, you know, he absolute brilliant genius, and so, you know, there is this I think, tendency for people to think about, you know, unique quirks of human personalities and stuff like that as, you know, medicalized, as needing to be cured. And you know, sometimes this happens when people discuss things like autism or ADHD, and, you know, the question isn't necessarily how to make their brain more normal or more typical. Rather, it's to enable them to live, you know, fulfilling lives, to you know, enable them to operate in, you know, environments and in situations that, you know, they would otherwise find very, very difficult, if not impossible. But then also enable them to exploit any potential unique capabilities that they might have, as, you know, the other side of the coin of how difficult it can be to have those conditions. LSD, we can talk about LSD. Ian, have you heard of GPT-3? Oh, hey, that's good to see, man. It's the most complex AI. Was wondering if emergent behavior is ubiquitous. I have not. Oh, that sounds really interesting. Oh, jeez. Scott, sorry about that, man. I didn't see that. The bottom of my screen is a little, like, obscured. All right. Is it working, Scott? Can you hear me?
Okay, there we go. It's on the countdown, so cool.
Awesome.
Was that working?
Yeah. What's on your mind?
Cool. Okay, well, actually, one quick question I've been wondering about for the past couple of weeks. But before I ask, you mentioned about the evolution of medicine and surgery and the methods what we consider barbaric, man. Back when the first month or so of the pandemic, when everyone was saying, you know, wash your hands, someone shared the story of, I can't remember the doctor's name now. He was Hungarian, and he's basically the guy who invented hand washing for doctors. And none of his colleagues wanted to believe it was a real thing. And they thought that you could just deliver babies after doing an autopsy, and it was fine. And they didn't wonder why the mortality rate was so high in the hospital. They thought it was necrotic particles. They didn't realize it was just microorganisms, because they had no concept. And he was trying to tell people, and they, again, wouldn't believe him. It became more and more belligerent that they hadn't committed, and then he was beaten because he was committed against his will, and he got gangrene from his beating as admission and died from it. He died from an infection, and he was credited with preventing infection in medicine, basically. It was just a very tragic story.
Yeah.
I can't remember his name. It's upsetting. But my question was, so when with all the free time, I mean, I'm still working a lot, but spare time at home, I was reading a lot about philosophy, I don't know, like humanism, existentialism, nihilism, all this stuff. And I'm wondering, are these guys, was this like their job? Was it like they go to work, they become a philosopher, or is it like they have an actual like practice and they're doctors or teachers, and this is like their hobby? Like martial artists, there's people that teach full time, but like I'm a martial artist, but like it's not my job. I just do it for fun. So these guys, is it kind of a mixture of both? Like was Plato, did Aristotle, did they go to work getting their job as a philosopher and a paycheck, or was that just like something they did in spare time? Nowadays, obviously, you can be a professor of philosophy and get a paycheck. Do you know how that kind of works over time?
Yeah, I mean, I have a friend who was an aspiring philosopher, just like in the UK, really brilliant guy, and he wanted to become a philosopher. And this is when I was, I'm a bit older than him, and so I was doing, starting the PhD in neuroscience, and I would ask him what do you? I have to do very specific things to get my PhD. I have to like do experiments and a bunch of experiments, and then try and make some sort of story that I then give to the scientific community, and that's the thing. That's like what doing science is, but it's like a tangible, well, sort of tangible, deliverable, right? And so I'd ask him like, what is it that you do? Like how do they grade you? And it's all just writing. It's like it's a lot of writing, and ultimately the goal is for you to write either a very, very technical philosophical argument, like using, like, I don't know if you've ever seen what logic in its formal discipline looks like. It looks a lot like math. It's not a lot of numbers necessarily, but it looks like an equation. So there's like things like that, but ultimately it's writing. Like that's what they do. I think it's wonderful, and I'm glad that it is a discipline that we sustain culturally. But I agree, it is sort of like, so what do you just like? Do you even need an office? Like, why do you even go to work? Just like you're just thinking, Yeah.
Very cool, thanks. And then before I go, real quick, I don't know if you saw a message a week or two ago that there was I'm trying to get some of this Belgian triple barrel aged from the brewery here and just figure out a way to ship it to you. Anyways, it didn't matter because the next day when I went back, it was gone.
Oh God.
So I got a couple growlers filled up with some other stuff, but I couldn't get the one that was. I figured I got like 5 ounces of it the one day, and then that was it.
That's really nice of you, man. I appreciate the thought, though. That's awesome. Thanks, man.
All right, take care.
Good talking to you. Yeah, like, the story of the Hungarian, I guess scientist or physician, it's not rare. Like medicine is like notoriously averse to change and like paradigm shifts, but it does change. Science is the same way, right? You really need to have a lot of proof if you're going to demonstrate that, decades, if not centuries of scientists before you were all wrong, right? But it happens. It totally does happen. Can I ask a quick question? Yes, of course. Oh, you're calling in. I see. Enoa. That's a very pretty name. All right, let's see if we can continue connecting. What's going on? Hey, are you there? What's your name and where are you calling from?
Hello?
Yep.
Well, I guess I have to call back. I cannot hear you at all.
Are you sure? Let's try a little bit more. Are you... Ah, darn. Okay. Sorry about that. Thugga. You could stay home and think. Yeah, it'd be lovely, right? Where I am, you are also. Yeah. How do you snap out of a routine without taking shrooms? I mean, how do you stop a habit or something like that? You don't need. It's not like psychedelic mushrooms are the only thing that enables you to, alter your routine behavior. I guess fundamentally it would be to derive enough motivation, true like emotional motivation, to promote doing the harder thing or doing the thing that is unfamiliar to you. Invest emotional salience or let's say emotional significance to why you want to change this habit. I think we have a tendency to underestimate the significance of emotion. Emotion is like one of the most critical facets of our consciousness that is like the rudder that drives our behavior. So that's what I would do. Hey, are you there? Can you hear me this time?
Yes, I can hear you. Sorry for my English. So I was saying I'm French. I had a question. I've been following your podcast for a while now, so I'm glad to finally be able to talk to you. What would happen if we could get rid of all the receptors, like someone getting drugs? If I think correctly, you get some drugs in the body, receptors get triggered and delivers another substance. What happens if we can get rid of the receptors in question?
So,
The biggest drug.
gotcha. Well, let me just make sure let's try and come up with a practical example. So, like, let's say somebody is addicted to morphine or addicted to heroin, And what would happen if we could just like literally get rid of all the receptors that heroin binds, right? Yeah, it's a great question. So first of all, I mean, that is sort of what we do when somebody's overdosing on opioids like fentanyl or heroin or whatever. We essentially do that pharmacologically. We administer something called naloxone, right? And that blocks all the receptors that the other opioids bind. That doesn't get rid of the receptors though. So the problem with that, and let's speculate that, hey, why don't we do that with like nicotine receptors, nicotinic acetylcholine receptors, or so the problem is that all of those receptors are there. They're not only there just by chance, and they're the only thing that they do is enable us to experience the experiences of heroin or nicotine or tobacco, right?
But they have other purposes?
Yeah. So they other neurotransmitters bind those receptors. So for example, nicotinic acetylcholine receptors, they're one of the most complicated family of receptors, a bunch of different kinds. And they underlie things from like memory, emotion, cognition, appetite, a bunch of different things. And it just so happens that nicotine binds those receptors. And as a result, the experiences that you have are involved with emotion, memory, right? Exactly. And so that's why when somebody quits smoking, their memory becomes disrupted. It's because they're at this deficit of acetylcholine, which is the neurotransmitter that would normally bind that receptor. And so the same would go for, mu opioid receptors, which are the receptors that heroin, fentanyl and so on bind, oxycodone bind. Those receptors, those mu opioid receptors, regulate emotion, maternal attachment, these types of, human bonding, these types of things, and also pain sensitivity. And so if you were to get rid of those receptors, you'd probably,
In case of withdrawal.
Right, yeah, that's right. So during withdrawal,
In case of withdrawal.
that's right. So if you're in withdrawal, that's why, you become so depressed. Sorry, go ahead.
I think we are a little bit out of sync. I will just end the sentence. In case of withdrawal, you were saying that emotion can get involved, but are they mild reaction, or is the person really getting mad, or will really lose all his memories, or drastic things like that, or it's mild reaction to emotion, like you say that it's related?
So I guess I'm not 100% sure what you're suggesting, but let's let's just get to it. So like if you were to literally eliminate those receptors genetically, right, and you could theoretically do that, then the entire system that relies on this specific component of the system to function would be thrown completely out of whack, and you might be in excruciating pain without those receptors. And so unfortunately it's not so simple. Otherwise that we could treat a lot of addictions with just the antagonists, the chemicals that would block those receptors, and that just doesn't work for anything other than resuscitating somebody from overdose of opioids. A treatment for nicotine or tobacco addiction is to give that person a drug that actually does something very, very similar to nicotine, just not quite as strong. And so you're not removing the receptors from the equation, you're actually stimulating them, just in a more controlled way. But yeah, I mean, it is a sort of frustrating thing, particularly for addiction neuroscientists, because it's unfortunately more complicated. All right, man. Thanks so much for calling in, and thanks for
Thank you very much for that answer, and I will leave the man for somebody else.
Right on. Well, thanks for calling, man. Really interesting topic. Okay, I have a question about addiction. If we can intervene. Oh yeah, there you are. Sorry about that, man. Hey, Roletti. Am corona positive from 23 days. Should I stay at home or get out? If you're positive for COVID-19, you should stay home, and hopefully you don't need medical attention. Must be a bad connection. Sorry for that, calling from France. Yeah, maybe there's something up with the call-in systems right now. The receptors work beautiful while high. Yeah. Is there a relationship between genetics and being smart? Very interesting, very controversial topic. The answer is yes. That genetics are the thing that you inherit from your parents. You have no choice over the genes that you inherit, and they are what are essentially the one way to think about them is like they're like the recipe to make a cake, right? You can make a perfectly respectable cake if you follow these directions. But as we all know, it's not like you can cook the most delicious cake with the perfect recipe from some French chef if you have never done it before, right? The environment also plays a significant role, right? Like if I was trying to bake a cake, there'd be like what is it, Daniel Tiger playing in the background, or Sesame Street or something playing in the background. There'd be my wife is trying to work, and my baby is like trying to climb up my leg and trying to touch the oven. And by the way, she found a way to slide something into the space between the front of the door of the oven and the back of the door of the oven. And it's impossible to get out. Like, I'm sure we'll have to literally take apart the oven, but God, how are you so brilliant in this specific respect? Anyways, and so despite the fact that I have the recipe, there's nothing particularly complicated about cooking. I will fail to make a good cake. That's sort of like the relationship between your genome, your DNA, and the actual expression of those genes. It's not one-to-one. There have been, for a long time, intelligence research predates really modern neuroscience. And so it's a discipline that's sort of in its own silo in a way, or has been. And more neuroscientists, as with essentially every other discipline, is just like gobbling up, it's being applied to these questions. And of course, if you're going to understand intelligence, what do you really have to understand? The brain, right? Consciousness. And so I think it's a fair invasion of that discipline, particularly because that discipline, it just doesn't have the tools. It's really a sub-discipline of like psychology. Although some political scientists have waded into that debate as well. But for a long time, the assumption was not only do genetics play a very large role in determining intelligence, but they are the only thing that determines intelligence, right? However, and I don't think anybody today would argue that that genetics plays no role in intelligence, but I think a lot of people would argue that it is more complicated than that. It is the recipe for the cake, not the cake itself. Yeah, but definitely a relationship. Okay, sending wrong messages killed my sister. Wow, sorry to hear that. Not to mention endocannabinoid receptors that are important for sensory coordination. Yeah, right. I assume you're referring to the topic that our friend in France brought up. Yeah, I mean, endocannabinoid receptors are like very interesting, very strange signaling system. They're among the most widely expressed receptors in the human body. There's several different flavors of them, but they can do wild things. Like they can dimerize with other receptors, and so you can have like a CB1 dopamine receptor. This is something I've been meaning to read a lot more about, and I just haven't really gotten to it because I never really had a reason to for my PhD. But yeah, they do a lot of stuff. They're sensory coordination, emotion, memory, appetite, it's almost everything, right? That like they're involved in so many, and that's why cannabis has such weird effects, right? It makes you laugh, it makes you hungry, it makes you forgetful, it makes you sort of happy, not like crazy euphoric, but like it can, and it's just this like wild, rather than like a drug like cocaine, which just like makes you very irritating to be around. Yeah, it's just like it makes you super happy and euphoric and excited, and immediately it makes you bipolar. That's what it does. Okay. If ingredients are added out of order, precisely, yeah. If ingredients of the cake are added out of order, or rather than adding a heaping cup, you add a sort of flat cup. That's a different amount of flour or whatever. So yeah, totally. My pleasure. Thanks for calling in. Enoa Maora. Enoa Amor. Is it cool? And no, I really like that name. I have another question. Does Cas9 protein play a role in your field or even your day-to-day? Yes. I assume you're referring to CRISPR-Cas9. So CRISPR is, still relatively novel technique that YouTube question. Oh, and graphics still up. Thank you, Joy. Hi, Ian. Saw an article. Body causing consciousness. Basically, if you just were a brain, you couldn't create consciousness. Cryogenics. Your thoughts may be a different form of consciousness. Yeah, I think it's very, very difficult to speculate what it would be like to be a disembodied brain. Partly because, if you were just a brain in a vat, you would have no sensory experience, right? Well, that's not quite true. But your sensory experience would be so different, right? Because the brain itself relies on our sensory systems, ability to touch receptors, pain receptors, photoreceptors in our eye to enable us to see specific patterns of photons, little membranes essentially in our inner ear that enable us to hear compressions of air molecules. The brain relies on those sensory receptors to define our environment for us. And so if you were to just remove those inputs by removing the body, you would deny the brain of that information. However, that doesn't mean that there wouldn't be spontaneous activity in my daughter's knocking on the door. She's learned how to knock. There she is. she's like cosmically adorable and brilliant. And you've all experienced this. You've all experienced spontaneous sensory activity in the absence of any actual incoming sensory activity. So for example, when you close your eyes, it's not like you just see blackness or maybe you do, or maybe you haven't really scrutinized what you're experiencing. You see sort of little patterns of light, sometimes in specific patterns, right? Sometimes you'll see a circle of light and it's just sort of undulating or something. I remember when I was growing up, the way I would go to sleep, I'm terrible at sleeping, is whenever I would close my eyes, I'd see this donut of light. And it would grow and it would get smaller, and I would just focus on this donut of light. I wasn't looking at a light, and it persisted. It wasn't an after image, I'm sure you've all played with this when you were younger, at least, where if you have close your eyes for a while, you open them and then close them really quick, you get this imprint, right? It's almost like a silhouette of what you were looking at. This is obviously true when you look at actual lights, right? If you stare at a light, you have this after image there. And that's in the absence of incoming sensory information. So that's just spontaneous activity that's arising from a bunch of... The after image thing is a little bit more complicated, but when you're just seeing phosphenes is what they're called, these little patterns of light when you're lying there trying to fall asleep with your eyes closed, that's spontaneous neurobiological activity that's occurring in the absence of any external sensory information. And so that would inevitably happen if you were disembodied. And I think it's just impossible to know. Despite the fact that you can have that spontaneous activity, you're never totally unmoored, right? You're never totally without a sensory anchor. Typically, our primary sensory anchor, the heaviest part of that anchor is vision. But it's not like when you're sleeping and it's quiet. It's not like there's no external sensory information coming in, right? There is still some light in your environment. It's not like you're in a vacuum of space, right? And it's not like just because it's quiet doesn't mean that the air conditioner isn't on or a fan isn't on, right? There's still incoming sensory information. So that anchors your sensory experience in reality, and it's very helpful to have that. Also, part of the reason for why sensory deprivation tanks can be very interesting and also very anxiogenic, very anxiety-inducing for a lot of people. A lot of people have very severe reactions to sensory deprivation. By the way, sensory deprivation, just before we get out of here, is basically you're in salt water, very, very heavily salinated, super saturated salt water, and enough salt in the water to make you buoyant. And the water temperature is ideal. It's the same as your body temperature. I've done this several times. I totally recommend doing it if we ever come to a new generation of human civilization past, beyond COVID-19. Totally recommend it. because I think that's as close as you can get to what it would be like to be a brain in a vat. You have given enough time, you can have very intense sensory experiences, and that's all spontaneously being generated in the brain. So I think it would be something like that, and I think just as sensory deprivation tanks can be very anxiogenic for a lot of people, I think the same would be true if you were just a disembodied brain. I do not agree, however, that there would be no consciousness. I just think it would be completely foreign, almost impossible for us to imagine. Okay. Yeah, CRISPR-Cas9, last thing. So yeah, CRISPR-Cas9 is a tool, rather new technology that enables us to very precisely edit genomes, any genome. We before CRISPR-Cas9, we could do that. We could alter genomes, but not nearly as precisely or effectively. And so yes, particularly when making transgenic mice. So for example, like for the topic you brought up, one of the things we can do to understand nicotinic pharmacology is to create mice or animals that totally lack a subunit, are incapable of creating a subunit for a nicotinic receptor, like alpha-5 subunit, or nicotinic receptors are pentagons basically. They're each corner is a subunit, and you can just take one away, and then you can see how the system functions in the absence of that subunit. That's like sort of the central technique of neuroscience, is to disrupt the system, perturb the system, and see what happens. And then you can learn more about what it is that you perturbed by seeing what happens. All right, I got to get going. Thank you so much for hanging out. I have a YouTube channel, youtube.com/anthropoid. I talked about essentially what it was that enabled humans to begin writing and written language several thousand years ago. Why not 100,000 years ago? What was it that enabled that to happen? Check it out, youtube.com/anthropoid. Or you can just search for Ian Anthropoid Brain. I have a podcast called Wired to be Weird. It's on iTunes and Stitcher. I talk about all the types of things we talked about today in greater detail. And I have a Patreon. I know it's tough times for everybody right now, but if you're in a position to be able to support this project, it's patreon.com/anthropoid, and I would deeply appreciate it. All right, that's it for me. Have a great rest of your Sunday and great beginning of your week. I hope to see you same time, same place, right here. Be there next week. See you there. See you guys. All right, YouTube, thank you so much for watching. I appreciate it. Have a great... How do I stop this now? What? Oh, maybe I just... Okay. Have a great rest of your week. And I'm always open to suggestions for how to do this better. So,